Welcome to Chemistry 2, Unit 3 on Thermodynamics. This is Lesson 2, Video 1. So we're going to start off this lesson talking about spontaneous processes. And spontaneous means that it is a process that can proceed without any outside intervention. So it's just something that happens. So if there is an animal lying dead on the side of the road, it spontaneously starts to decompose. It just happens. We don't do anything to it, it's going to decompose. Now we can do certain things to it to speed up the process, but it's still going to decompose. The opposite does not happen. So these processes occur in one direction. So we do not have a pile of black goo that was once a deer spontaneously come back together to form a deer again. So if something is spontaneous in one direction, it is not spontaneous in the opposite, and vice versa. So the reverse is not spontaneous. It'd be pretty freaky if it was. Temperature plays a role. So some processes that are spontaneous, and I'm going to start abbreviating spontaneous as spont, so I don't have to write out the whole thing. Some processes that are spontaneous at one temperature are not spontaneous at another. And we're going to see the different scenarios in which that is the case. So there are two things that contribute to spontaneity. One of them we've already looked at, and that is a change in enthalpy. So that is our delta H value. So endo or exothermic reactions. The majority of reactions are exothermic, which means that they have a negative delta H. And the majority of these reactions are exothermic, are spontaneous. But endothermic reactions can be spontaneous. And that is a little bit hard to understand, but most reactions give off heat because heat is a very disorganized form of energy. And if things give off heat, they're lowering their potential energy, and that makes things a little bit more stable. There's a lot of physics involved with this. But there are some endothermic reactions that can be spontaneous, so they have to take in energy, but it does it automatically. And that's kind of one of those, okay, there has to be something else that is in effect, along with the change in enthalpy, that can cause a reaction to become spontaneous. And that is a change in a new thermodynamic quantity called entropy. Entropy is going to be delta S. So S stands for entropy, and the delta means change in. And entropy is a measure of molecular disorder. So this is something that we artificially give values to. It is calculated. We have a table of entropies. It is part of your purple packet that you have. So there are different values for that packet I'm trying to find mine at this moment, and it seems to not be here. So let me pause the video and look for that. So 1 second. Here we go. Here is our entropy values, and they are all listed here. So we have enthalpy that we used last unit. We have entropy this unit. So a delta S would be a change in entropy. And the units are joules per mole Kelvin. And you have to be really careful because this is a measure of disorder. So if we have a positive delta S, that means that we are increasing the amount of disorder. So it's getting more random or messier. So if we have a positive change in entropy, it's getting messier. Think of entropy maybe with relation to how clean your room is. If you just let things go, it's going to become messier and messier. So entropy is increasing as it gets messier. If you have a negative change in entropy, that means that you are decreasing disorder. So it's getting less random or more structured. So in our next video, we're going to look at the second and third law of thermodynamics and how we can work with or look at the effects of entropy.